The phenotyping, evaluation and selection section is probably the most complex and time-consuming to complete. We use a section to capture traits that are evaluated and selected based on experimental data generated as described in the previous trial design section. That includes traits in your target product profile that are not selected through marker-assisted selection or phenotypic screening, as covered in an earlier video. However, understanding how to use data from field trials or greenhouse experiments to make advancement decisions and select new parents is crucial for optimizing your selection process. Therefore, thoroughly completing this section is essential for fully exploiting the genetic potential of your breeding population. The traits are sourced directly from the Breeding Portal Trait Catalog, so you should find all the traits that you included in your target product profile. We will now add yield under drought, which is an abiotic stress trait. If you're unsure about the correct category, you can check the drop-down menu where categories are listed alongside the traits and adjust your selection as needed. To remove an incorrect trait or category, simply click the minus icon. To fully understand the advancement and parent selection process, we capture for each trait the number of test locations and the evaluation unit, the statistical evaluation method used for data analysis, the advancement value and the advancement selection method, as well as the parent recycling value and the parent recycling method. As we start entering information for yield under drought, the meaning of these attributes will become more apparent. Providing the number of locations where a trait is evaluated might seem redundant after documenting the trial design in the previous section. However, certain traits such as biotic or abiotic resistances may not be evaluated at all sites. For example, yield under drought is measured at only one managed location in our breeding pipeline. The evaluation unit represents the genetic makeup of the entity on which you will base your selection, which may sound more complex than it actually is. The evaluation unit could be, for example, full subfamily, a half subfamily, or a single genotype. At this stage of our breeding program, we can assume that after several rounds of selfing, we have a more or less homozygous line. The method of statistical evaluation generally refers to a single record, an average of multiple records, a blue, or various versions of blob. Strictly speaking, blues and blobs are statistical properties rather than statistical methods. However, we decided not to complicate this section further, sacrificing some precision in terminology for the sake of user-friendliness here. We assume that we are combining our phenotypic information with mid-density marker data to predict genomic plots. The last 4 columns describe how we select new parents and make our advancement decisions. In both cases, we document the selection value and the selection method. The drop-down options for the selection value are somewhat similar to those for the statistical evaluation method. For example, if your statistical evaluation method is a single plant or an average of multiple records, your advancement value will also be a single plant observation or an average of multiple values. Conversely, if your statistical evaluation method is a genomic blob, your advancement method might be genomic estimated breeding value, genomic estimated genetic value, or a genomic estimate of general combining ability, depending on your breeding scheme and target. If you are unsure about the correct choice or feel that your approach is missing from the drop-down menu, please reach out to us. We're happy to help. In our example pipeline, we are working with the lines, and our advancement value will be a genomic estimated breeding value. Our selection method for advancing lines to the next testing stage will be independent culling, as we want to ensure that our candidate varieties meet or exceed a minimum threshold for yield under drought to qualify as a variety. Since we are demonstrating a line breeding program here, our parents are also selected based on their GEBV. However, in other breeding programs, the selection values for advancement and parent recycling may not always be the same. For example, in a hybrid breeding program, parents might be selected based on general combining ability, while hybrids for product development may be selected based on the total genetic value. For parent improvement, we include the trait yield under drought along with other traits in a desired gains index. This approach is generally more efficient and easier for improving our breeding population across multiple traits simultaneously compared to independent culling. To keep things simple, we have limited our example to 2 traits. In a real-world breeding pipeline, however, you will likely have many more traits in your target product profile to document. This may take up quite a bit of time. However, aligning your target product profile in the breeding portal with your selection strategy documented in the Breeding Scheme Manager will provide you with a powerful tool to communicate, discuss, and improve your selection strategy.